Download this code from codegive.com, link in the description below. Understanding and Tracking Unconfirmed Bitcoin Transactions in 2024, a detailed guide. This tutorial delves into the intricacies of unconfirmed Bitcoin transactions, their significance, how to track them, and how scripting plays a role. We'll explore the Bitcoin blockchain, its mempool, and provide code examples in Python to illustrate how you can monitor and analyze these transactions. This guide is updated for 2024, reflecting the current state of Bitcoin's network. The Bitcoin blockchain and the mempool, a foundation. Before diving into unconfirmed transactions, let's establish a solid understanding of the underlying infrastructure. The Bitcoin blockchain at its core, Bitcoin is a decentralized, distributed ledger. This ledger, the blockchain, is a chain of blocks, each containing a batch of confirmed transactions. These blocks are linked cryptographically, ensuring the integrity and immutability of the recorded data. Confirmation occurs when miners include transactions in a block and that block is added to the blockchain. This usually requires 6 confirmations, meaning 6 blocks added after the block containing the transaction, for high-value transactions to be considered irreversible. The mempool, memory pool. The mempool is a vital intermediary between transaction creation and blockchain confirmation. It's a temporary storage area where unconfirmed transactions reside. Think of it as a waiting room for transactions. Every node on the Bitcoin network maintains its own mempool. When you broadcast a Bitcoin transaction, it doesn't immediately land on the blockchain. Instead, it's submitted to the mempool of various nodes. Key mempool characteristics dynamic and volatile. The mempool is constantly changing as new transactions arrive and others are mined into blocks. Limited capacity. Mempools have size limits. When they reach capacity, nodes typically prioritize transactions with higher fees. Fee-driven prioritization. Miners are incentivized to include transactions with higher fees in their blocks, leading to faster confirmation times. Transactions with low fees might languish in the mempool or even be dropped if congestion is high. Node specific. Each node operates its own mempool. There's no single, globally shared mempool in the strict sense. Nodes communicate with each other to propagate transactions and maintain a relatively consistent view. 2. Understanding unconfirmed transactions. An unconfirmed transaction is simply a transaction that has been broadcast to the Bitcoin network and is waiting in the mempool to be included in a block by a miner. Until a transaction is included in a block and that block is added to the blockchain, the transaction is considered unconfirmed. Reasons for transactions remaining unconfirmed. Low transaction fee. The most common reason. Miners prioritize transactions with higher fees. Network congestion. During periods of high network activity, the mempool can become congested, and even transactions with moderate fees might face delays. Double spending attempts. While rare, transactions attempting to spend the same Bitcoin multiple times will compete for confirmation. Only one of the conflicting transactions can be confirmed. Nodes will reject the later double spend. Dust transactions. Extremely small transactions, known as dust, can sometimes be ignored or treated with lower priority. Miners might have policies against including them due to efficiency concerns. Orphan transactions. A transaction that refers to an input, previous output, that is not yet confirmed. The transaction is valid but depends on the confirmation of its parent transaction. 3. The role of scripts in unconfirmed transactions. Bitcoin transactions aren't just simple transfers of value. They are governed by scripts, Small programs written in Bitcoin script, a stack-based scripting language. These scripts define the conditions that must be met for the transaction to be valid and the recipient to spend the received funds. Asterisk script pub key, locking script. This script is part of the transaction output and defines the conditions required to spend the funds associated with that output. It's like a lock that needs a specific key to be opened. Common script pub key types include pay to pub key hash, P2PKH, pay to script hash, P2SH, pay to witness pub key hash, P2WPKH, and pay to taproot, P2TR. Asterisk script sig, unlocking script. This script is part of the transaction input and provides the data, signatures, public keys, etc., needed to satisfy the conditions set by the script pub key of the previous output being spent. It's the key that unlocks the lock defined by the script pub key. How scripts relate to unconfirmed transactions. Asterisk. The scripts involved in an unconfirmed transaction are crucial for its validity. When a node receives a transaction, it validates the scripts to ensure that the transaction is authorized and adheres to the Bitcoin protocol rules. If the scripts are invalid, the node will reject the transaction, and it won't enter the mempool. Example, simplified P2PKH transaction script, concept. Imagine a simplified P2PKH, pay to public key hash, transaction. One transaction output, locking script pub key, up_DUP up_hash 160 recipient _public _key _hash up_ verify up_checksig. 2 transaction input, unlocking script sig, signature public _key. When the node validates this transaction, 1. It executes the script sig followed by the script pub key. 2. The signature and public _key from the script sig are pushed onto the stack. 3. up_DUP duplicates the public key. 4. up_hash 160 hashes the duplicated public key. 5. The result is compared to recipient _public _key _hash using up_ verify. If they don't match, the script fails, and the transaction is invalid. 6. up_checksig verifies that the signature is valid for the given public key and the transaction data. If all steps succeed, the script evaluates to true, and the transaction is deemed valid. If the script fails, the transaction is invalid. 4. Monitoring and tracking unconfirmed transactions. Here's how you can track unconfirmed Bitcoin transactions using various tools and methods. 1. Block explorers asterisk. How they work block explorers are websites that provide a user-friendly interface for browsing the Bitcoin blockchain. They index all the transactions, blocks, and addresses. Most block explorers also show the mempool activity, including unconfirmed transactions. Examples blockchair, https://blockchair.com/ https://blockchair.com *blockchain.com https://www.blockchain.com/explorer https://www.blockchain.com/explorer block cipher https://www.blockcipher.com https://www.blockcypher.com using them you can search for a specific transaction ID, TX ID, to see if it's unconfirmed, its fee, and when it was first seen. You can also browse the mempool visualization to get an overview of the current network congestion. 2. Bitcoin Core RPC how it works Bitcoin Core, the original Bitcoin client, provides a remote procedure call, RPC, interface that allows you to interact programmatically with the running Bitcoin node. You can use RPC calls to query the mempool and retrieve information about unconfirmed transactions. *RPC commands *getRaMempool returns a list of transaction IDs in the mempool. *getMempoolentree tsid returns detailed information about a specific transaction in the mempool, including its fee, size, dependencies, and time first seen. *getMempoolinfo returns information about the mempool's size, usage, and memory limits. *code example, Python with Bitcoin RPC. Explanation *dependencies requires Bitcoin CLI command line tool, part of Bitcoin Core, and the subprocess and JSON Python modules. Make sure Bitcoin Core is running and configured with RPC enabled. Also ensure that Bitcoin CLI is in your system's path or specify its full path. *configuration replace your _RPC user and your _RPC password with your actual Bitcoin Core RPC credentials. Make sure RPC is enabled in your bitcoin.conf file. Also, verify RPC_host and RPC_port. *Bitcoin_RPC, method, params, function *. This function handles the execution of RPC commands using the Bitcoin CLI command line tool. *get_mempool_transactions, function * calls getRaMempool to retrieve a list of transaction IDs in the mempool. *get_mempool_transaction_info, tsid, function * calls getMempoolentree to get detailed information about a specific transaction. *get_mempool_information, function * calls getMempoolinfo to get overall mempool information. *if _name _equals =_main _:block * demonstrates how to use the functions to retrieve and print information about the mempool and a specific transaction. *error handling includes basic error handling to catch RPC errors. To run this code *1 save the code as a .py file, example mempool_tracker.py. 2 install Bitcoin Core and configure it with RPC enabled. 3 replace the placeholder RPC credentials with your actual credentials. 4 run the script from the command line, Python mempool_tracker.py. 3 third-party APIs How they work Many third-party services provide APIs for accessing Bitcoin data, including mempool information. These APIs often offer higher rate limits and easier integration than directly using Bitcoin Core RPC. Be mindful of security and trustworthiness when using third-party APIs. Examples Blockchain API, fee-based, comprehensive. BlockCipher API, free tier available. Blockchain.com API, free tier available. Code example, Python with BlockCipher API. Explanation Dependencies requires the requests and JSON Python modules. API key replace your _BlockCipher API key with your actual BlockCipher API key if you have one. Some endpoints are free without a key. Check BlockCipher's documentation for rate limits and pricing. *get_mempool_transactions_BlockCipher, function * retrieves a list of recent mempool transactions from the BlockCipher API. The limit parameter controls the number of transactions returned. *get_transaction_details_BlockCipher, tsid, function * retrieves detailed information about a specific transaction from the BlockCipher API. Asterisk error handling asterisk includes error handling for API request failures. Asterisk example usage asterisk demonstrates how to use the functions to retrieve mempool data and transaction details. To run this code asterisk 1. Save the code as a .py file, example block cipher _mempool.py. 2. Install the requests library, pip install requests. 3. Replace the placeholder API key, if needed, with your block cipher API key. 4. Run the script from the command line, python block cipher _mempool.py. V. Practical applications of tracking unconfirmed transactions. Asterisk transaction monitoring asterisk track the status of your own transactions to ensure they are being processed. This is particularly useful during periods of high network congestion. Asterisk fee estimation asterisk monitor mempool activity to estimate the appropriate transaction fee to ensure timely confirmation. Many wallets now do this automatically. Asterisk security auditing asterisk analyze unconfirmed transactions to detect potential double spending attempts or other malicious activities. Asterisk market analysis asterisk gain insights into network activity and transaction trends, which can be helpful for trading or investment decisions. Asterisk API integration asterisk build applications that rely on real-time transaction data, such as payment gateways or transaction tracking services. Asterisk understanding miner behavior asterisk monitor which transactions are being included in blocks to understand miner fee preferences and mining strategies. 6. Important considerations and limitations. Asterisk mempool instability asterisk the mempool is dynamic, and transactions can be removed or replaced due to fee bumping, example using replace by fee, RBF, or node-specific policies. Don't rely on a transaction staying in the mempool indefinitely. Asterisk node-specific mempools asterisk different nodes may have slightly different mempool contents. You're only seeing a partial view of the network's mempool. Asterisk privacy implications asterisk monitoring unconfirmed transactions can reveal information about transaction senders and recipients. Be mindful of privacy concerns, especially when dealing with sensitive data. Asterisk API rate limits asterisk third-party APIs often have rate limits. Be sure to adhere to their usage policies to avoid being blocked. Bitcoin Core RPC also has resource limitations. Asterisk security risks asterisk when using third-party APIs, ensure they are reputable and secure to protect your data. Asterisk replace by fee, RBF transactions can be replaced with a new transaction with a higher fee, effectively invalidating the original transaction. This is an important consideration when monitoring unconfirmed transactions. The replaced transaction disappears from the mempool and is replaced with the new one. Asterisk child pays for parent, CPFP. If you control the output of an unconfirmed transaction with a low fee, you can create a child transaction spending that output and attach a higher fee to it. This incentivizes miners to confirm both the parent and child transactions. 7. Advanced concepts, mempool policies and script analysis. Asterisk mempool policies asterisk Bitcoin nodes implement various policies to manage the mempool and prevent abuse. These policies can include asterisk minimum fee rates asterisk a minimum fee rate below which transactions will be rejected. Asterisk maximum transaction size asterisk a limit on the size of individual transactions. Asterisk chain limits asterisk limits on the number of unconfirmed ancestor and descendant transactions for a single transaction, to prevent chain building attacks. Asterisk anti-DOS measures asterisk rules to protect against denial of service attacks. Asterisk script analysis and security asterisk analyzing transaction scripts can reveal potential vulnerabilities or patterns of fraudulent activity. This requires a deep understanding of Bitcoin scripture. Tools exist to disassemble and analyze Bitcoin scripts. You can look for unusual script constructs, unusual spending patterns or attempts to exploit vulnerabilities. This is a very advanced topic. 8. Conclusion. Tracking and understanding unconfirmed Bitcoin transactions is a crucial skill for developers, researchers, and anyone involved in the Bitcoin ecosystem. By using block explorers, Bitcoin Core RPC, or third-party APIs, you can gain valuable insights into network activity, transaction status, and potential security risks. Remember to be mindful of the limitations of each method, respect API rate limits, and prioritize security and privacy. Keep in mind that the Bitcoin landscape is constantly evolving, and staying up to date with the latest developments is essential. The above code examples and guidance provides a great foundation for building custom applications that leverage mempool data. Good luck and happy coding!